Hello, myself Darpan Suluja. By profession, I am computer programmer. In this video, we will discuss about application of quadratic equation. Our first problem is maximize profit. This says that cost of an item and quantity sold is often linear. We assume that increase in price will decrease the demand, and we have to get the selling price at which we will get the maximize profit. So our selling price is 20, quantity sold is 2030, quantity sold is 1800. Means to say, as our selling price is increasing, our demand or quantity sold is decreasing. Our cost of production is $10. Selling price is our variable along x-axis, and dependent variable quantity is our y-axis. The slope of the line, that is rate of change, is equal to -20. Slope intercept form of line, which is y is equal to mxb, for m is slope of line and b is y intercept. In our case, quantity solved, that is y, that is q, is equal to 2000, slope is -20, and our x value, that is selling price along the x-axis, is 20 plus b. We have to calculate the y intercept b, that is 2400. Now let's draw the line with given data. With this given data, we have the line equation y is equal to mx plus b. Y is 2000, m is -20, x is our selling price, and our intercept is b, that is 2400. So our line equation which takes the value of x and return us the value y. Our x-axis is selling price and our y is quantity sold. So return value is -20, that is slope of line, and x our selling price plus 2400 y intercept. And now we will draw the equation of line. Y is equal to we have taken the x from 0 to 56 value, that is 0, 10, 20, 30, 40, 50, and y is equal to line equation, our function line equation, and we are passing the value x. Then we have draw the plot, plt dot plot x comma y comma x comma y comma marker points for data points BO, line equation, shift enter. So this is our function for this selling price and quantity sold, and this is our line. This is our y intercept at the value 0 is 2400. Our slope, line of slope, is -20, which is showing that the line is decreasing as the selling price is increasing. So quantity sold, Q, depends on selling price, and our equation for that is Q, this y-axis, is equal to -20 x plus 2400 selling price. Now profit formula says that total revenue minus total cost. P is equal to total revenue means total sale. Total sale means total quantity into sale price, that is sale price is 20 into quantity sold 2000, that is our total sale, and our total cost is equal to quantity into 10, and our quantity equation is -20 into x plus 2400. After putting this Q value into this profit equation, we will get our profit equation, final profit equation, that is -20 s square, our selling price, plus 2600 s minus 24,000. From this equation we will get the our selling price value at which we will get the maximized profit. And when you draw the this equation, the vertex of this equation's graph is -b/2 is the selling price at which we will get the maximized profit. So let's do it graphically. Vertex of the graph is -b/2a is equal to 65. So 65 is our max selling price at which we will get the maximized profit. Let's do it graphically. Our profit equation x and return minus 20 into x square plus 2600 into x minus 24,000. Shift enter. Our x value is 20 to 110 and 10. Let's get the y value. Y is equal to profit equation and pass the value of x and then draw the graph. X and plt dot plot x comma y comma bo, and this is our graph. Here thus at 65 our maximized profit is 60,000. This is the point where our profit is maximized. Now the another example is throwing a ball. A ball is thrown straight up from 3 meters above the ground. Means to say at the time t is equal to 0, the height is 3 meters with a velocity of 40 meters second. Our initial velocity is 40 meters per second. When does it hit the ground and what is the maximum height of the ball will reach at which time? So we have to, our equation is, our expression is h is equal to 3 plus 14t minus 5t square. So let's start it by defining a height equation and a equation EQ. EQ is equal to 3 plus 14 into t minus 5 into t square EQ. Shift enter. So 3 plus 14t minus, so this is our equation. Now first problem, when does it hit the ground? When does it hit the ground? T represents the time, represent the x-axis, and height represent the y-axis. Means to say when the height will be 0. So we have to get the time at which a height will be 0. So factor the equation and get the time root of the equation, that is when the equation value will be 0. The factor EQ t minus 3. T is equal to 3. Put the value of t is equal to 3 into this EQ dot substitute t comma 3 and 0. So at time 3 height will be 0. So when at the time 3 sec the height will be 0. The ball will touch the ground. Now we want to calculate when the value of height will be maximum, at which time the value of height will be maximum. For that we have to calculate the vertex of this equation. To do that, first get the vertex x, vertex x is equal to minus b by 2a, minus b is 14, minus 14 by 2a, 2 into a is our 5, minus 5 vertex x. At time 1.4 the ball will reach at maximum height. Now we want to get the maximum height. So vertex y and put the value of x into the equation. For that we have defined the equation def height equation takes the value of time and return this. So height equation, and we will pass the value of 1.4, run vertex y, and 12.80 is the maximum height. At time 1.4, the ball will reach at the maximum height of 12.80. So let's do all these things. Let's solve all these things now graphically. For that, we have values of x, that time from -1 to 4 is equal to 20. Let's calculate the value of y, that is at maximum height, the height at different time. So height equation, we will pass the value of x, and now draw the plot. Plt dot plot x comma y comma bo, and this is our graph. I have created 3 annotate to show you initial height, time after which the will hit the ground, and maximum height. Now our problem, now again read the problem. A ball is thrown straight up from 3 meters above the ground. So at time t is equal to 0, our initial height is equal to 3. Our maximum height at time is equal to 1.4 is 12.80. At maximum height it will reach at 1.4. Now at when the time is 3 sec, it will touch the ground. Our maximum height is equal to 0. So in this video we have seen the two problems, maximize profit and throwing a ball. For now it's time to say bye. We will soon meet in the next video.